Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. ALC. KOH favors elimination, E2, which is bimolecular, second order. ACH. KOH favors substitution, SN1 or SN2. E2 requires antiperiplanar geometry. SN2 is bimolecular, second order. SN1 is unimolecular, first order. Optical activity depends on whether the product has a chiral center or is a mesocompound or achiral. Moving on to the next step. 1, 2, 3 trichlorocyclohex 4-Na with double bond already in ring, making it cyclohexene trichloride treated with ALC. KOH. ALC. KOH causes E2 elimination, second order, bimolecular matches are. E2 elimination removes HCl from the trichloride. The product retains a chiral center or has a non-symmetric structure due to the existing double bond and remaining substituents, giving an optically active product matches P. So, A, P, R. Moving on to the next step. 1, 2, 3 trichlorocyclohexane, no double bond, with C1 Cl wedge, C2 Cl dash, C3 Cl wedge, treated with ALC. KOH. ALC. KOH causes E2 bimolecular, second order matches are. E2 elimination of HCl gives a dichlorocyclohexane. The specific stereochemistry of the starting material, C1 and C3 both have Cl on wedge, C2 has Cl on dash. After elimination, the product has a chiral center. The product is optically active matches P. So, B, P, R. And for the final step. 1 chlorocyclohex, 2 Na, allylic chloride, Cl and H on wedge at C1, treated with ACH. KOH. ACH. KOH with an allylic chloride. Allylic systems can undergo SN1 ionization to resonance stabilized allylic carbocation, giving racemic mixture, or SN2. The substrate is an allylic chloride, secondary allylic position. With ACH, KOH, SN1 is feasible due to allylic stabilization. However, the answer given is P, R, optically active, second order. This means SN2 occurs, second order, and since SN2 gives inversion at a chiral center producing a single enantiomer, the product is optically active. The carbon-bearing Cl is a secondary allylic carbon. SN2 proceeds with inversion optically active product and second-order kinetics. So, C, P, R trans 4-methylcyclohexyl chloride, Cl on wedge at C1 CH3 on wedge at C4, meaning both are equatorial or both axial in some conformation, treated with ACH. KOH. ACH. KOH with a tertiary or secondary alkyl halide. This is a secondary cyclohexyl chloride at C1 with a methyl at C4, trans configuration. The carbon-bearing Cl is secondary. Trans 4-methylcyclohexyl chloride, in the chair conformation where Cl is axial, CH3 is equatorial, trans relationship. The substrate is secondary. With ACH, KOH, secondary substrates typically undergo SN2, but cyclohexyl systems are somewhat hindered. However, the answer indicates unimolecular, S, and optically inactive, Q. SN1, unimolecular, gives a carbocation intermediate, leading to racemization. Optically inactive product matches Q and S. Actually, for a secondary substrate, SN1 can occur if the carbocation is somewhat stabilized or conditions favor it. The product from SN1 is racemic, optically inactive. So, D, Q, S, wait, the given answer states D, Q, R, not Q, S. Let me reconsider. The answer given is D, Q, R, meaning optically inactive and second order. SN2 on a cyclohexyl, secondary substrate with a KOH, SN2 gives inversion at 1 chiral center. Trans 4-methylcyclohexyl chloride has C1 as a chiral center and C4 as a chiral center. SN2 at C1 gives inversion at C1 producing CIS-4-methylcyclohexanol. The CIS-4-methylcyclohexanol, C1 and C4 are both chiral centers, but the molecule is a meso compound, plane of symmetry, making it optically inactive. And SN2 is second order. This explains DQ, R, SN2, second order, R, product is CIS-4-methylcyclohexanol, which is a meso compound, optically inactive, Q. Final matching. A, P, optically active, R, second order E2. B, P, optically active, R, second order E2. C, P, optically active, R, second order SN2. D, Q, optically inactive meso product, R, second order SN2. Therefore, the correct answer is A, P, R, B, P, R, C, P, R, D, Q, R. Therefore, the correct matching is A matches P, R, B matches P, R, C matches P, R, D matches Q, R.